This program is a co-production of Access Alberta and the Southern Alberta Institute of Technology. The construction of core walls is a specialized aspect of concrete forming. Cores are the central shaft of the building, which usually contains stairwells, elevators, washrooms, and mechanical rooms. Cores are often constructed before slabs, walls, and columns. A major problem relating to core forming is the fact that work has to be undertaken in a hollow shaft. Conditions are often hazardous for the workers and for those below. When working inside a core, a protective platform below is an essential part of the job. The platform is supported on beams attached to previously built tie holes. Another problem in building core walls is that the inside form is always plumb and typical. However, the outside form must be modified periodically because the wall thickness of the core is reduced as the building progresses upwards. This is because the bottom floors have to carry more weight and wind stress. In this structural steel building, the concrete core is built well ahead of floor construction. It is, in effect, a building within a building. Notice that there are a large number of doorways and box-outs involved in core construction. In core construction, form support brackets are used to support and adjust the interior gang forms. The form is supported by brackets which are bolted to a threaded insert. These threaded inserts are cast into the concrete wall at the top of the formwork as each floor is built. The inserts are located at strategic points to coincide with reinforced edges of the gang form. The brackets can then be adjusted to position the form at the required height. Since there is no floor inside the shaft, plumbing the walls is accomplished by adjusting and leveling the brackets. The inside of a shaft is a very restricted space. This requires special techniques for stripping forms. Core forms must be collapsible to allow them to be stripped out. One method of stripping an inside corner involves the use of a removable beveled corner. Once the corner is removed, the forms are free to be moved up for the next pour. Another method of making the forms easily strippable is to design beveled edges on the gang forms. The gang forms can now be prefabricated into rigid corner sections. Once the crane has positioned the form, final alignment and the closing of the joints is undertaken by the core crew. Most core forms require some manhandling to place them into position. When using steel forms, a heavy filler plate is used as a stripping method. Removing the plate reduces the size of the form for easy stripping. When using an all-wooden system of forming shafts, the inside form can be designed to be collapsible. Mitering of the inside corners allows the formwork to be collapsed inwardly. When forming the slab, the exterior core form must be stripped out and lowered to the ground. The interior core form can be left in place to act as an edge for the floor slab. This procedure requires that the interior form be taller than the exterior form. This allows the interior form to overlap the concrete placed earlier. When overlapping the interior form with the previous wall placement, a minimum lap of plywood to the concrete is required. This is because the bottom of the form has bulged from the pressure of the concrete. Attempting to connect this to the top of the wall is difficult because there is minimal bulging at the top. If there is an excessive lap, the form profiles will not match and leakage will occur. Before closing up the second side, concrete spacer blocks are placed on the slab. These are designed to maintain the required wall thickness. The concrete blocks are required because taper ties have no built-in form spacers. Similarly, at the top of the core form, spacing is achieved by using metal top yokes. A major aspect of core forming is the requirement to position and adequately secure a variety of openings. Doorways, for example, must be accurately positioned vertically. These elevator doorways need to be plumbed very accurately from one floor to another. Placement of the concrete must be sequenced so that equal force is exerted on both sides of the door frame. In order to avoid any possibility of movement, very secure anchorages must be installed. Horizontal strutting within the door frame is designed to prevent the doorway from collapsing under the force of concrete. Since door bucks are reused for each floor, they must be especially durable. A scarf joint in the header beam allows for quick and easy stripping. Scarf joints require vertical support. Door bucks need to be braced, both vertically and horizontally, in order to resist the force of concrete. All openings need to be built as strongly as the outside formwork. This beam pocket is formed with dimension lumber since it is being constructed around rebar. When constructing bulkheads around rebar, dimension lumber is easier to fit and to strip. Using plywood for bulkhead construction is not practical and would require far more time to install and strip. When forming pockets or inserts for service ducts, ease of stripping is most important. Boxes are slightly tapered and wrapped with polyethylene to prevent the concrete from bonding to the formwork. This is the result of the box out. Notice that styrofoam is used here to save labor. When rebar protrudes, cutting and fitting of lumber would be very time-consuming. Core forming is very similar to general gang forming. However, specialized procedures are involved which solve the problems posed by core construction.